This video on how to factor a perfect square trinomial starts with an example like this. If I look at that, that is a perfect square trinomial, and I am telling you this is a perfect square. We could go ahead and get started splitting this up into two binomials. However, it might be easier to examine this first and see if there's something simpler we can do before we start. If I look at 9x squared, 72, and 144, I see that they're all divisible by a 9. So that is greatest common factor factoring first, which is the first step you should always do in factoring. Pull out a 9, and I get 9x, or x squared, minus 8xy, plus, and 144 divided by 9 is 1 and 16. And then I get 16y squared. What we have remaining is still a perfect square trinomial. Now, how do I identify a perfect square trinomial? Well, if I look at the patterns, I see that I have a perfect square here, and I have a perfect square here. My biggest degree, two terms, largest degree, or terms of largest degree, both are perfect squares, and the middle term here would come from these two. So what I like to do, instead of messing with it too much, is just kind of factor it and check it. So what I'm going to do is I'm actually going to factor this as a perfect square trinomial, which means that it factors into two identical binomials. This is x, this is x, this right here is 4y, and this is 4y, and this sign here, in order for it to have a negative here, would have to be minus and minus. So notice how they're identical. And if I FOILed them out together, my inner term would be a negative 4y, and my outer, or negative 4xy, and my outer term would be a negative 4xy as well, which would add up to get negative 8xy. So as a last step, really all I have to do is rewrite this as x minus 4y quantity squared. Here's another example of one where I still have to take out a greatest common factor. I'm actually going to take out a negative x, so I can switch all the signs, making that 121z squared minus 22z, and that would be plus 22z, and then plus 1. As I look at that, I suspect that this might be a perfect square trinomial because this is a perfect square and this is a perfect square. And 121 square rooted is 11 times 2 is 22. It looks like it's going to work. So I'm going to factor this as 11z plus 1 quantity squared. I'm going to go ahead and write the squared. And just check that 2 times 11z times 1 is the middle term, which it is.